be able to see my screen.
Very good. All
Good.
right, and to the audience, maybe we'll just do a quick thing. Is audio and video coming in good for all of you? Maybe just let us know in the sessions chat. Cool. Okay, I'm going to jump off. We're here. Let us know if you want us to jump back on for anything, and take it away.
Wonderful, thank you. So I'm gonna take my smooth night operator voice and present this StarkNet voting workshop that we'll have tonight. I'm Henri Lieutaud. I'm a developer advocate for StarkNet, and I'm joined with my wonderful colleagues, Ariel, who's a product manager for StarkNet, and Yonatan, who's working on engineering on StarkNet. So today we're gonna explain to you a bit what is StarkNet, what is Ciro, and a few things about writing smart contracts in StarkNet that you can use and build your applications on. So the first question is, obviously, what is StarkNet? So StarkNet is a layer 2 of Ethereum. It's a general computation platform, which is secured by Ethereum layer 1. It allows you to write smart contracts that are general purpose. You can write any kind of logic in these StarkNet smart contracts, and they allow you to manipulate Ethereum assets. These can be ERC20, ERC721, or really any kind of assets that you want to have on mainnet. It allows you to interact very smoothly with L1. Actually, you can have logic implemented on L2 that has effects on L1 in a very short amount of time, meaning in a very short amount of execution time. The cool thing about StarkNet is that contrary to Ethereum, where the execution of your transaction happens on every node of the network, StarkNet pushes execution of your smart contract to the edge of the network, meaning then that only one node of the network, which is called the prover, actually execute the payload of your transaction and generates what we call a proof of correctness. In turn, every node of the network actually verifies the proof of correctness and updates its state. So this means intuitively, if the computational work is done by only one computer instead of all the computers of the network, it lowers the cost of execution because you're not bounded by the smallest machine you want on your network, and you still give extremely strong guarantees that the execution was done correctly. You're not trusting the prover to do the work correctly. You're trusting mathematics that the job was done correctly. So lowering the cost of execution of your smart contract has two really nice side effects. The first one is that you can scale the number of transactions you can do in a given block on L1. So you might have heard of the crazy numbers that DYDX is doing with StarkX, which is a bit different than StarkNet, but I won't get into that right now. But basically, some applications like Sorare or DYDX or ImmutableX are able to pack a very large number of transactions in a single execution proof and lower the cost of a single execution. And that's something we see today, and everybody needs it, right? But there's the other side of that, which is also very interesting, which is that you can do more transactions or you can do more complex one. And that's really hard to define. I can't really tell you, oh, you could do this, you could do that, because it's still very much uncharted territory. And it's something that I'm really curious to see you guys explore. So definitely go look for that on revolving around StarkNet. So you might have heard about StarkNet, but you also might have heard about Ciro. So what is Ciro exactly? So Ciro is a language that was designed by Starkware. It's a programming language that allows you to write provable programs. So compared to a classical programming language that compiles to CPU instruction, Ciro compiles to arithmetic instructions which have specific properties. And these properties allow a very neat trick, which is if I show you a program, I show you its inputs and its outputs and a proof of validity, you're able to verify the proof and be certain that the output is valid without actually executing the program itself. And this is a paradigm that you might be used to in the blockchain world. The parallel I like to use is with proof of work. If I show you a specific block hash, you're confident that some work has been done without having to actually do the work yourself. Well, in a way, what we do is conceptually the same. I show you a proof and you're sure the work was done correctly, but you don't have to do it yourself. Now, the really cool thing with Ciro is that Ethereum has opcodes that allow the EVM to verify such proof. This means that you can execute a Ciro program off-chain, send the proof on-chain, and have a smart contract actually verify this validity proof. So now it's not just you, a user, that I try to convince that a program was executed correctly. I can prove it to an Ethereum smart contract, and I can automate the shit out of my app. I can do a lot of things very cool with L1, right? So basically that's it. You write a Ciro program outside of L1, and you can prove to L1 that something happened. How does that link exactly to StarkNet, right? Because StarkNet is a computation network. What is the link with Ciro? Well, that's a really cool thing. StarkNet is a Ciro program. StarkNet is an operating system which has a VM, which is called the Ciro VM. And this VM has storage, and it allows the execution of Ciro smart contracts inside this VM, right? And so this whole VM is written in Ciro, and you can prove that this VM was executed correctly and that it executed all the sub-payloads correctly. So you can prove to Ethereum layer 1 that your layer 2 network executed all its smart contract correctly. And that's really all there is to it, right? So there's Ciro, which you can write general purpose programs with. And we have implemented one specific program, which is StarkNet, which allows you to execute sub-Ciro programs, which can be arbitrarily complex inside this VM and have it interact with layer 1, right? So that's a general high-level overview of what we're building. And yeah, I don't know if I have it on my slide, but where is this exactly? Like, how can you use it and when will it hit mainnet? Well, it's been in testnet since July, and the alpha will hit mainnet at the end of this month. So you can start using it on mainnet at the end of this month. All right, so that's for the conceptual introduction. Now about what we're going to be working on today. So today is a hands-on workshop. We want to teach you how to use a StarkNet smart contract, because everything I've presented is nice, but you may still be thinking, well, but still Ciro is not Solidity. And you're right. We do have a transpiler in the work that will allow you to port your Solidity contract to StarkNet, but that's not what we're covering today. Today we're covering writing an actual StarkNet smart contract, which will give you more efficiency when running your smart contract. And you'll see that it's not that different from Solidity concepts and the layout and the syntax of using your contract. So you're going to learn about the general syntax of StarkNet smart contracts. You're going to learn how to import modules, which we call built-ins. You're going to learn how to declare, use variables, create functions, have them interact, and we're going to talk also about composability. So how you can write a contract and have it interact with another contract in StarkNet. While we will be doing all of this, and this is nice, we won't have time to cover everything we would like you to learn. So we won't cover, for example, L1 to L2 communication, meaning how do you send a message and how do you manage assets on L1 from L2 and vice versa. We're not going to cover how to build a front end for your StarkNet app. And we're not going to cover, we're not going to get into detail about the StarkNet architecture, like, for example, the network architecture, what kind of nodes there is, how do you send the info to the prover, and all of this stuff. But be sure to, if this topic interests you, this certainly interests me, be sure to join our community. You can read more about what we're building on our documentation, and mostly you can join the party on Discord. We have a lot of content there, community calls and things like that. So be sure to join, and you'll learn more about what it is we're building. Okay. So for the actual topic of the contract you're writing today, you're going to be working on a voting system. So some of you might be familiar with the first tutorial that is offered by Remix when you start working on Solidity. It's somehow similar. You're going to learn how to create a contract that will allow users to create polls, to register user for them to vote on polls, and then you'll have functions that allow users to vote on polls. All nice and dandy. You'll learn how to do functions, variables, get comfortable with StarkNet contracts, and things like that. All right. And with that, my mission is done. I'm going to stop sharing my screen, and I'm going to ask if Ariel can join and take it from there.
Wait, just before you do that, I just want to point out that in the Q&A, there's actually 2 questions that were asked. Maybe we could actually say them out loud for the video viewers later, and maybe you could just help answer those. So the first one, I'll ask if that's okay. Could you briefly explain what would change for the end user? Can the end user still use MetaMask?
So I think, so the first answer to this is that this is very much to be defined, right? I mean, the actual user experience of Ethereum was not defined by the people who developed Ethereum. It was defined by people who built on top of Ethereum. So if you want to have a say in that, start building on StarkNet. That being said, it will probably look like Ariel tools where you move assets from one network to the other, and then you'll have different tools, be them wallet extension, browser extension, that will allow you to interact with the network. And depending on technical choices, you might be able to use MetaMask or maybe other wallets. In the first versions, I'm not sure it's going to be MetaMask, but we're currently working on an implementation for account abstraction with Argent and OpenZeppelin.
Very cool.
Does that answer the question?
Yeah. I mean, sure. A person can answer, since it can maybe ask more in the chat if there's anything else. The second one is about, is anyone building tools to generate ZK snark validators in Cairo? So maybe you want to, yeah, because you're not really doing snarks, you're doing starks.
Exactly. I see Ariel twitching. So yeah, we're using a bit of a different primitive. We're not using snarks. We're using something that's called Stark. I'm not gonna get into what is different between the two. That's an interesting question, and you should come ask it. But I don't think that's the topic for tonight. And I don't think we can transpile thing from Socrates. I'm not sure about this specific question. So yeah, I don't have much to say about that. Ariel, do you have insight on this?
Well, I can say that there is some interest in developing snark validators in Cairo, actually as a StarkNet contract. So I think there's some people who are actively working on it, but outside of Starkware. So this is still open. If you want to be the first one to have a ZK snark verifier written as a StarkNet contract, then go ahead. We'll be happy to publicize it.
Cool.
Same goes for ZK Starks validators in Cairo, which is also something that interests us.
Very cool. Henry, if there's any more questions, I see one more in the chat. Maybe you just want to answer in chat so that Ariel can continue with this presentation.
Sure. So Ariel will present the workshop, and I'll be here answering questions.
Very cool.
Okay. Thank you.
Take it away, Ariel.
Hey, so let me just share my screen. Okay, so I'm guessing you see the presentation. Okay, good. So first of all, before I'll get into what we're going to do today, I'm Ariel, I'm product manager in Starkware. And right now we should be sharing a few links in the chat. So the first link is to this Notion document that you see right here. So as we go through the exercise and different parts of the contract, you'll have the code in a copy-pastable format. And for those of you who can't really wait for the answers, you have the complete code in the end of the document. Other than that, the place you're actually going to write your code is the StarkNet playground, which is also, you should be seeing the link in chat right now. So you'll have the example contract here, so feel free to just remove it, write your contract, and attempt to compile it. Okay, so I think that we're all set. Let's start talking about the actual contract that we're writing. So I'm going to basically walk you through writing a voting contract in StarkNet. Okay, so let's start with the very basics of a StarkNet contract. So every StarkNet contract starts with a specification of a contract, which is as opposed to a native Cairo program. So Cairo programs don't have this line. The second line that you see right here is a declaration of what built-ins we're going to use. So Henri talked about it briefly. I'll just say that you can think of built-ins as precompiles. These are certain functions who are not implemented in native Cairo for optimization purposes. So for example, you see right here that we're using the Peterson built-in, which is the hash used throughout StarkNet. So you later see how exactly we're going to use it. For now, we're just declaring that it will be used somewhere. You can see more built-ins right here. We'll talk about the CDSA built-in later. After that, you have the modules that we're going to use. So here we're just importing different structs and library functions. Okay, for example, the hash2 function, which we're also going to use a bit later, the verify CDSA signature, and a few others. Okay, so let's continue with the basics. So storage variables, just like you would have them in Solidity, you can define variables which are part of the contract storage, although with a slightly different syntax than perhaps what you're used to from Solidity. Okay, so here you can see the definition of two storage variables. You can see that they're storage variables by the storage var decorator. Okay, and this is the name of the variable. So you can see that the syntax for declaring a storage variable in StarkNet is actually defining a function. So you can see that this function takes one parameter and returns one value. So the way to interpret it is that this is in fact a mapping from a key to a value. So it takes the key and it returns the value corresponding to that key. And for example, the second storage variable that we see here takes two arguments. So you can think of it as a nested mapping of mappings. So you need to specify two keys to get the value. So simple as that. Okay, something else that you might be seeing here is the type of all keys and values, which is felt. This is the basic type in Cairo. It's short for a field element. And you can think of it as analogous to Uint 256 in Solidity. For our purposes, it's just a number from 0 to a very large prime. Okay, so let me just say what those storage variables represent in our context. So public owner, public key, poll owner, public key is actually a mapping between a voting poll ID and the public key of the poll owner. This owner will be the only one permissioned to allow voters into this specific poll. So you can't vote on a poll unless you have the owner's permission. And then you have the mapping of the registered voters. So it's a mapping between a poll ID and a public key of now some voter, and a mapping to a flag which indicates whether or not this particular voter is indeed permissioned to this poll. Okay, great. So we're already getting into our first exercise. So here we're just asking you to add two more storage variables. So the first is voting state, which is a mapping from a poll ID and answer, which is a possible answer to the poll. In our case, simply yes or no, represented as a felt. And the value is the number of votes for this particular answer. And another variable, voter state, which indicates whether or not a voter has voted on a given poll. So we're going to want to be able to track the voter state, so he won't be able to vote twice. So here again, the parameters is our poll ID. The key consists of poll ID and the voter's public key. Okay, so please take 5 minutes, and of course, let us know if there are any questions. Feel free to ask in chat. And, good luck. We'll have a few more of those as we move along. A question in the Q&A: what is the difference between built-ins and the modules, functions? So the modules and functions you saw after the built-ins are actually implemented in Cairo. They are actually written as Cairo instructions, whereas built-ins are not. So the analogy is pre-compiled code. So these are not Cairo instructions that are getting through the entire compilation process.
So Ariel, I took the liberty of copy-pasting some questions that were in the chat. Maybe what we can do is, while people work, we can answer a few of these questions, and then we'll correct the exercises. So if you want to focus on your work, please feel free to mute me. So the second question, actually, I'd be glad if you can answer it. How easy is it to embed Cairo into other blockchains? What is the critical requirement? I'm guessing you need your blockchain to be able to verify Starks. I'm not sure if something else was done on that.
I'll just add that, okay, the critical requirements is being able to verify in that specific blockchain's language the execution of Cairo programs. So yeah, just like we were able to write this verification in Solidity. I hope I understood your intention correctly. Yeah.
Okay, the next question we saw interesting is, what is the status of the Solidity to Cairo transpiler? So the team at Nevermind is working on it. I posted the link to a Twitter announcement that was a few days ago. Basically, they have small smart contracts transpiling, and they're able to have different smart contracts talking with one another. How complete will that be? Well, Yonatan mentioned that you're not going to get the best performance out of the Ciro VM using transpiled code, but you're still going to be able to do a lot of things. And somebody asked also, who's going to run StarkNet nodes? And my answer was everyone. We're building a decentralized permissionless network, so that's the end game for us. There's not really an interest to build something else. That being said, the infrastructure today is fairly centralized because it's in the process of being built. So that's what we're doing. So look out for decentralization steps along the deployments that we'll have of StarkNet. The following question is, what is the Web3 equivalent to interact with Cairo smart contracts from a web app or an automation bot? We have a few tools that are being built by the community that allow you to connect your program to StarkNet contracts. Ariel, what are the most relevant to you, do you think?
I mean, there are some projects for interacting with the probably the prominent and closest one is Argent's wallet. We also have our block explorer, which allows you to interact with StarkNet and send transactions. There's the Ciro Lang, which we'll refer to it in the end when we'll give you links to additional resources. So there's no like a complete Web3 analog, which is already a mature library that allows you to completely interact with StarkNet. But it's coming along, and we're also working on an API for a node, some Web3 analog. So yeah, stay tuned.
And I think we've passed the 5-minute mark, so maybe we can keep the relevant questions for what next while you correct the exercise.
Yes, okay. So let's go through the solution of the first exercise. I'll refer to the data availability question in our next intermission. I like this one. Okay. You see here that now the number of storage variables grew a little bit. So we have our voting state, which is a mapping from poll ID and then a possible answer to the number of votes for that answer. And we also have the voter state mapping, which takes a poll ID and the public key of a specific voter and returns a flag that indicates whether or not this particular user has already voted. Sorry about that. Let me move to present mode. Okay, good. Okay, so now we have the storage that's ready to support our voting logic, but now we need to actually implement that logic. Okay, so this is the poll initialization function. So you can already see the external decorator right here. This means that you can interact with this contract by accessing this function. Okay, so this function in each poll, it takes, under the curly brackets, you see 3 arguments. So this syntax is actually called implicit arguments. And it takes 2 regular arguments, which are the poll ID and the public key of the poll owner. So to initialize the poll, you need to specify the poll ID and your public key. To say a word about those implicit arguments, we're actually using those under the hood to access storage variables. So if you wonder what are they doing here, while you don't see an explicit mention of this, so that's why they're there. Okay. Obviously, more information on how exactly implicit arguments work can be found in our Ciro documentation. Okay, so what is the logic of poll initialization? So we need to verify that this poll is not already initialized. So for this, we have our poll owner public key mapping. So we're just gonna read from this mapping under the key, which is poll ID. Okay, you see this let syntax, which simply defines a reference whose name is poll ID taken and whose value is the return value of the read call right here. Okay, so now at this point I should mention that the default values of all mappings in StarkNet is 0. So unless you've initialized the poll with a non-zero public key, then this value is going to be 0. So here we're asserting that is poll ID taken equals 0, meaning that no user has substituted his public key under this poll ID. And if we were able to pass this assertion, then we are able to get to the next line, which simply writes to this mapping our public key, which we've received as a parameter, to this poll ID. So note that this variable, so reading take is a function that takes 1 argument, the key that you want to read from, and writing takes 2 arguments, which is the key you want to read from and the value. If this was a nested mapping, then the number of arguments for write would be larger. Okay, so now we're simply returning after we've successfully initialized the poll. Okay, this leads us to the second exercise, which you have a slightly longer time for. Okay, so now we want you to write the declaration of a function which is called register voter, okay, who takes as parameters poll ID, the voter public key, and 2 additional values which we're calling R and S. These are going to be the signature of the poll owner of this particular poll. which signifies that this user the poll owner indeed allows this particular voter inside this poll. Okay. And start implementing this function body. So I'm not, well, you shouldn't actually do the signature verification at this point, but you should simply read the current poll owner. We already saw how to read from storage variable. Later, we're going to do some verification on it. And then update the registered voters storage variable. So recall that we had a registered voters variable, which indicates which voters are allowed under which poll. So it makes sense that the register voter function will eventually update the register voters storage variable. Okay, so good luck, and we'll talk about it in 15 minutes.
Hello again. For the break advertisement, how can we call these questions? Okay, so you have 15 minutes. I put a timer, and we can answer questions in the meanwhile. So there are some questions. There's an easy one. I mean, an easy one. There's one I can answer, and then there's one I leave up to you. So the first question is, how does data availability work in StarkNet? Do we need to keep all data on L1, or is it supported on StarkNet L2? So the data availability problem is very much an area of research in the L2 space in general. The way it works in StarkNet is that, so the way people usually think it works is that you need to push all transactions to layer 1 for them to be exploitable later on. We don't need to do that. So for example, that's the way optimistic rollups work, right? You push the transaction that's called data, and if needed, you open them. This doesn't work like this in StarkNet, because once you have the proof of execution, you don't need the transaction to re-execute the payload because you know the execution was done correctly. What you need to have on L1 is the state. So the way StarkNet works today is that every time we push a new proof of execution, we put a state diff so that you can recompute the state from the past state and be sure that the transition that led to this new state is correct. This is the first construction of StarkNet, and it's what is called a ZK rollup, meaning that you have all the data to reconstruct everything, but we're exploring how we can make this more efficient or tailor-made to the user's need by exploring other constructions. So one is Validium, where you basically just post the proof of execution, but you don't push the state diff to mainnet. So this is obviously cheaper, but it has decentralization issue. And we're mostly exploring the space between both. Like, how can you publish some data, not everything? And it's very much an area of research. And if you have meaningful contributions you want to do on that topic, please join the discussion with us on Discord, where, I mean, your ideas are valuable. So come and talk with us. And related to that, there was another question in the chat, which was basically, how are transactions ordered in StarkNet? So the actual question, I think, is, how does MEV extraction work in StarkNet? And for that, I would say that this is very much an open question. We're still designing that. There are a few things we're thinking of, and if you have ideas on how we could tackle that, please join the discussion. And there's this question I want to leave to you, Ariel. Do Starks and Snarks do the same thing, just differently?
So I wouldn't say they do the same thing. Eventually, if you call the same things proving arguments about the program execution, then the answer might be yes. But one major difference I can think of, other than the properties of the construction, the cryptographic assumptions, and the technical details like this, a difference in the statements that we're proving is that snarks are usually built around arguments of a specific size. So, for example, circuits of specific size. While the Stark construction that we're using actually allows you to prove the execution of arbitrary programs. So my program can take 10,000 steps or 1,000,000 steps, and I can still use the same protocol for proving it. Obviously, the proof will require more resources. I'm eventually limited by by my hardware, but I'm not limited at the protocol level. It's not that if I'm moving to a greater number of steps, then I need to change my setup somehow. I don't need to resend any parameters. There's actually nothing different going on. I just send the program and start executing the protocol. And regarding I just want to add, emphasize a point that Henri mentioned in the data availability area, that it's an important distinction that for example, for optimistic rollups, the transactions have to be sent somewhere, because otherwise you can't submit a fraud proof. You must see the transactions themselves. While in ZK rollup, you have a guarantee that the execution happened correctly, and you just need to keep track of the current state in order to be able to produce new blocks. So what we do currently in StarkNet is publish the state diffs, not the transactions, as call data, not storage, on L1. And we're exploring different possibilities, perhaps different L2s that will hold the current state. So this area is still under research, but yeah, we're definitely exploring a wide spectrum of data availability solutions. And our intention is that in the final design, you'll be able to choose the data availability trade-off that is suitable for your needs between, for example, price and security.
Ariel. So Geoff has a question. Will StarkNet allow deposits, exchange and withdraw of NFTs, or is it just for fungible tokens? Geoff, free your minds from the shackle of the EVM and from all the other ZK solutions you've seen so far. You can do anything in StarkNet. You can manipulate ERC20, you can manipulate ERC721, you can create different kind of objects, you can create specific custom application connectors on your smart contract on L1 and have it be manipulated by L2. StarkNet is a general computation platform. You can do anything on it, and as long as you define the way L2 and L1 communicate together, then you can exchange arbitrary messages, so you can do anything. And I know it's not a very precise answer, but the answer to your question is yes, you can manipulate NFTs, and you can do a lot of things with that. I'm not sure if you want to add something, Ariel, or...
No, I completely agree. If you like to move NFTs, then yeah, you can move NFTs.
The way the bridge works between because right, we're 7 minutes in, so I hope all of you guys are working well. We still have time, so maybe I can talk a bit about the L1 to L2 bridge. How does it work exactly? So the way it works is that the bridge of StarkNet actually takes as input a proof of execution and a state diff, and it will also have an inbox and an outbox of messages. So your L1 smart contract can go right into this bridge, a message, which can be arbitrary data, that once the block is picked up, will be picked up by L2 and sent to L2 in an inbox in L2. And you can have your smart contract on L2, pick that message, and execute it, right? And it works the same way, the other way around. You can have your L2 smart contract, send a message to L1, and once a new state is committed on L1, the fact or the message that you're sending will be pickable by your smart contract on L1. So you can implement any kind of logic, right? It can just be simple booleans, it can be arbitrary data, you can RLP encode, it can be whatever you imagine. So the same question before, after that is it the same with ERC777, ERC1151? I'm not sure what these are, to be honest, but since the bridge of communication between StarkNet and L1 is general purpose, if you designed a way to exchange things, you can do so. That being said, the bridge is general purpose. We published code for an ERC20 bridge. I'm not sure if it's ERC721, but I know some people from the community are working on that. So you'll be able to use for standard bridges out of the box, but other than that, you can execute you can design them. I was gonna say fairly simply. Maybe I'm not objective, but it's doable.
Just mention that Elperin are working on developing standard contracts, and you can just view them on GitHub. You can see how ERC20 is implemented by them, or ERC 721. Yeah.
Yoni is asking, how complex can StarkNet program be? Is there StarkNet gas? So these are two questions. I'm going to tackle one and then the other. So the first one is, how complex can a StarkNet program be? Arbitrarily complex. You might have seen, if you're following us on Twitter, we pushed some content from a guy called Guilty Gyoza, which is doing like physics simulation, and you can see things move on your screen. It looks nice. There's the free body problem, and it looks cool. But what is going on exactly? So when you have a game on the blockchain, usually what you have is that you will have the transfer of assets that will happen on chain, but the actual calculation for the game will happen off chain, or if they happen on chain, it will be fairly simple computation. The cool thing about StarkNet is that since you push execution to the edge of the network, you're able to have very complex calculation be executed and prove that the execution is correct. So I want to think about Worms 2. I'm sure I'm not the only one who played that game, right? You have small worms and you shoot at each other. Try to imagine writing a smart contract program. Try to imagine writing a program that calculates the trajectory of a bazooka shoot and then it hitting a wall and all the shrapnels going around. Hard, but doable. Now try to imagine writing this in Solidity. The first thing you're going to think is like, gas-wise, it's not doable. It's not going to work. Well, you can write these things in StarkNet, and only one node will execute it, and it will prove to you that the shooting of your bazooka had this actual trajectory and this exact kind of damage. So that's the kind of complex simulation computation we're talking about. And that's what Guilty Gyoza is actually working on. He's working on a physics engine with which you'll be able to manipulate objects and have them have trajectory and interact with each other, which is a very interesting primitive for gaming, because now you have games that you're able to play on-chain with the actual gameplay happening on-chain with verifiable contracts. So that's for the complexity part. Now the second question is there StarkNet gas? The shortest answer is not yet. Of course, computing things has a cost, so there will be cost associated with your program, with executing your program, but this is not fully defined as of today. In the beginning of the network, it's not going to be very expensive, but then it's still an area where we need to define exactly how we're going to charge users for that. One thing I want to mention regarding that is that in general, in StarkNet, computation is cheaper than storage. Since you're updating storage on L1, this has a higher cost than computation. So that's why like calculating a trajectory is cheaper than actually storing the results on chain. I don't know if you want to add something to that, Ariel.
That sounds accurate. Yeah.
So the following question is, if one node can execute a transaction and others are verifying how race conditions are prevented, I mean, if Alice makes a swap on one node and Bob makes a swap on another, how the common state is built? Well, you'll have a prover which will basically compute the state and push the proof of execution. So proving will happen at one entity. How this entity is chosen and how the order of the transaction is chosen is still an area of research. And if you want to learn more, do join the discussion on Discord to learn more. And then we still have a minute and a half, so I'm going to skip on Snark versus Stark. Somebody asked the question earlier. I don't know if you heard the answer. If you have more questions regarding Snark versus Stark, please give more details about what you want to learn. And the following question is, how does the business model of Starkware work? How do you guys plan on monetizing your work? It's not a technical question, but it's a good one. It's still an area of research. We figure that if we build something cool that people use and has usage, something will show up. Starkware is a company developing ZK rollups, but StarkNet will have a life on its own eventually. So the objective is not to have an enterprise platform permission, it's to have a decentralized network. So we'll see what happens. And we still have 30 seconds to go before correcting, so I'm going to let Ariel correct the exercise thing.
Just before I start, let me answer the can one hope to understand Starks without getting very deep into the math. So it depends what is your motivation. If your motivation is to understand Starks and understand our protocol, then the short answer is no. You're going to have to get into the papers and understand all the definitions they're relying on and so forth. But if you want to develop for StarkNet and write StarkNet apps, then you simply don't care. You don't care about it. It's just like saying that a Solidity developer doesn't need to know exactly how transistors work. So from your point of view, it's just an elementary part in the system which works, and you can work around it. So an experienced Solidity dev knows the EVM very good, but he doesn't really care about transistors and how stuff actually running. So in that, it's sort of analogous to a StarkNet developer which really knows Cairo and really understands the Cairo VM, but has no idea about Starks and how exactly the proof of execution works. I mean, those things are pretty much orthogonal. Okay, so I'll move on to the exercise solution. I hope you all got it right. Sorry about that. Okay, so this is the declaration of the register voter function. So you see our regular implicit parameters are still with us, and we take as parameters the poll ID, the public key of the voter, and R and S, two additional values, which I remind you represent the signature of the poll owner on this particular voter public key and the poll ID. So the signature should imply that the owner of the poll has given permission to this particular voter to vote. Okay. So you see that the last line in this function will eventually be to add this voter to the register voters storage variable. So we're going to update this storage variable under the key poll ID and the public key of the voter, and we're going to write 1. So 1 implies that this voter is registered to this poll ID. Okay, so now to the more advanced verifications. Okay, so first of all, we're asserting that this poll is initialized. So how are we asserting that this poll is already initialized? So you can't register voter to an uninitialized poll, obviously. So we simply read the poll owner from the poll owner public key storage variable. So we're reading the public key of the owner, and we're asserting that it is different than the default value, reminding you all that the default value is always 0. Now, so I have the initial part, the last part. Now all that remains is to verify the signature. So first of all, we need to get the message that the owner supposedly signed on. So again, he should sign the poll ID and the public key of this particular voter. So how it works in ECDSA is that you first hash the message and sign on that hash. So this is why we're using the library function, which we imported before, hash2, which hashes 2 arguments to 1. Okay, and we feed it the poll ID and the public key of the voter. Again, you see this implicit argument. Here, the left side is simply the formal name of the argument, hash pointer, and we're substituting to it this Peterson pointer, which represents our hash built-in. Again, so if you want to really understand how implicit arguments work, I refer you to the Cairo docs. Okay, so now we have a reference to the result of hash2. This message is now a reference. reference to the result of the hash on the poll ID and the voter public key. And we're ready now to actually verify the signature. So we're just calling another library function, verify ECDSA signature, on what arguments? The message, the public key, and which public key? The public key of the owner, because he's the one who's supposed to sign, and finally the signature values, the R and the S. So two important library functions here, hash2 and verify ECDSA signature, and we verified everything at this point. So we verified the poll is initialized, we verified the signature. Now we can update the storage variable and actually register the voter. Okay, great. Okay, so we talked about, okay, this is, we didn't mention this, so this is another built-in, the ECDSA built-in, which is used which is used in this verify ECDSA signature function. So again, these are things that happen behind the scenes. Okay, we're asserting that the value is not 0, and okay, this we actually talked about. Okay, so now we're adding another function to the voting logic. You can see here a new decorator, the view decorator, which indicates that this particular function is not allowed to change the contract storage. So this is a read-only function, okay? And what does it take as an argument outside our standard implicit arguments that allow accessing storage variables? So it takes the poll ID as an argument, as a key, and it returns now two values, the number of no votes and the number of yes votes. So as the name suggests, it simply returns the current voting state, okay? So right now, it's your job to implement the body of this function, and you have 5 minutes for it. If you don't want to know exactly, if you don't want to get in for this, then stop here. And if you do, then it simply requires you to read twice from the storage variable which we defined previously. And we will keep track of it. We will maintain it later. So far, we haven't really maintained it, but assume that this storage variable indeed maintains the current state of the vote. Okay, so please take 5 minutes, and we'll continue with our regular habit of answering questions.
Launch the timer for 5 minutes. So, I've seen some questions that were answered in the chat. So do look for answers in the chat too. So one question is, how big is the overhead for StarkNet programs in comparison to native implementation? For the example of Worms, is it 10x or 100x or something else? I don't have an answer for this question. I don't know, Ariel, if it's clear to you and you want to answer it. Otherwise, I'll just keep it and look for the answer and give it later.
Talking about the actual size of the program, like bytecode, you do have some overhead because Cairo is, let's say, a lower level than, for example, Python, and you don't have libraries that implement all sort of numerical logic yet. So there is going to be some overhead in the program size, but you don't really care about this in terms of execution. If we're talking about execution differences, I can't really give you a concrete number, but again, we want you to get the mindset that computation is cheap and storage is the more expensive part. But yeah, so computation is cheap because eventually the only overhead here is submitting the proof of execution, which is much smaller. So we don't really care how long the computation took. So I'm guessing 100x is exaggerated, but I can't really give you a more concrete estimate at this point.
Cool. I'll answer one quickly. Does the tooling automatically create a ZK verifier in Solidity for L1? No. What happens is that what you're doing in StarkNet is proved in the context of StarkNet, and the execution of StarkNet, so the execution of your old layer 2 is proved to Solidity. So there's one contract where you prove everything that happens on StarkNet. And this place where you verify that everything is correct as an inbox and outbox message. So that's from a Solidity developer perspective, all you have to do is handle messages that go to and from L2. You don't have to worry about building a verifier, having a circuit, having a setup, things like that. You just need to handle messages, which is nice. I'll answer another one, which is what tools are there for developing TDDing? I'm not sure if that's a typo or something, but basically for developing Cairo contracts, Hard Hat, Solidity. So there's a set of tools that is being developed by the community and other partners. You'll find plenty of information in the chat. We're going to publish a link with community tools, and do join Discord because there are new people joining quite regularly, actually, and sharing their tools, and so everything is being built. I'm not going to lie, it's a bit more nascent than, it's fairly more nascent than Solidity, but there's a lot of tooling emerging, so there's a lot of things to simplify your life. And this one I'll let to you, Ariel. Are the costs of function arguments in StarkNet meaningfully greater than, say, inputs to Sharp? Is that explicit?
I'm not sure exactly what you mean, because Sharp, it actually stands for Shared Prover, and it is a service that we run at Starkware, which allows us to prove simultaneously the execution of different programs. So now Sharp is in production with several applications. So we have Immutable X and Sorare, I believe. So these are both two apps which both require different proofs of completely different programs. But using Sharp, they can share the burden of the proof. So this is unrelated to what we're doing here with writing a StarkNet contract. You could ask eventually the execution, the advancing of the state in StarkNet, running the StarkNet OS, which Henri mentioned briefly at the beginning of the workshop, can be proven in Sharp. But these are two different types of objects, like the contract function and Sharp. So I can't really answer that. And just about test-driven development. So we have our testing framework, which is documented in our site. And some of the tools that Henri mentioned are building on top of our testing framework. So yes, you can currently, we do have a testing environment, and it is pretty dynamic. We improve it as we add more features to StarkNet.
Okay, I'll answer one last one very quickly before we move on to answer. The question by Rahul is, how often does the mailman come from L1 to L2? And so how do you think about data availability and set submission in terms of frequency? So, and correct me if I'm wrong, Ariel, right now you have to think there's a state committed every, I think it's like in terms of hours, right? Every 8 hours. But this is pretty much something that may evolve with time. If we have more volume or more necessity, this frequency can probably increase. Am I saying something stupid? Is it accurate?
It's right now it's in the order of hours. It can be improved with, for example, recursion, if or when we will have it. But
wonderful. So yeah, in the orders of hours for now, but work in progress, and we want to drive it lower. Okay, with that, let's go to the answers. Thank you.
Okay, great. I'll just also mention we have faster checkpoints than actually submitting the proof. So the proof accepted on Ethereum will be the greatest degree of finality, but we'll have something before that for apps which need to be more live, yeah, and don't really care about waiting for the proof and can settle for a lower degree of finality. Okay, so let's go to the answer. Okay, so hope you were all able to do it. So we're just defining two references, simply reading from the voting state. Again, notice the keys that we send. So to get the number of no votes, we send the poll ID and 0. And to get the number of yes votes, we send the poll ID and 1, and we simply return those two values. That's it. Okay, let's move on to now verifying the vote. So far, we verified things that are related to the owner of the poll, but now we actually need to verify things that are related to the vote itself and the voter. Okay, so we have the verify vote function. Okay, and note that this function has no particular decorator. This means that it is a helper function, which we will call in one of the either external or view functions. Okay, so again, the implicit arguments that we're used to, and a few standard explicit arguments: the poll ID, the public key of the voter. Now, again, notice the difference between the owner and the voter. The vote, the value that he is intending to vote, and again, two values representing the signature now of the voter rather than the owner. Okay, so the first verification is simply that the vote itself is binary. It's either 0 or 1, and we can verify this by asserting that this multiplication equals to 0. This will only be 0 if the vote is either 0 or 1. Okay, so now we're actually coming to the next exercise, and you now have to implement the rest of the verification. So first of all, you need to verify that this particular voter is allowed in this particular poll. This is why we're maintaining the register voters storage variable. The next thing you need to know is that this particular voter is not attempting to vote twice. This is why we're maintaining the voter state. And lastly, you need to verify the signature. So you already saw how to verify the signature. But right now, it's the signature of the voter rather than the owner. And think about what he's signing on. So what he needs to sign on is the poll ID and his vote value. Okay, nobody else should be able to vote in the name of this public key. Okay, so you have 15 minutes to implement the rest of the functions. You can see the previous code in the Notion documents. And good luck.
Thank you, Ariel. Putting the timer back. So I'll take some questions, and then there's another thing I want to talk quickly about. So the first one I'm going to take is, what are your thoughts on ZK Sync and their implementation of the ZK rollup? Well, we believe L2s are the future and ZK rollups are the future, so we're always happy to see more people interested in the same topic and building toward the same decentralized future we are. So we're excited to see what they will release once it's visible and usable. It's always interesting to have the perspective of other teams on the same topic we're trying to solve. So very curious to see what they have once they release it. And the second question is, would writing a GPU shader-like program to manipulate a large memory buffer be possible? Ariel, is it something?
I have no idea what exactly is the meaning here.
Me neither. Okay, so let's put this in the back of our head, and if we can, if Yoni, you can give more insight as to what it is you want to build, please write it in the chat, and we'll try to answer it. Thank you. And the other thing I wanted to mention really quickly, that I saw somebody in the chat saying like, "Whoa, this is interesting. You can do more stuff, more computation," and yes, it is the case. Computation in StarkNet is fairly cheap. It's very cheap, so you can do a lot of stuff. And I'll give you one brain teaser about things that you could do. Right? So imagine you want to do a snapshot to have people vote, depending on how much token they hold. Right? In order to do that snapshot, you have to do it on chain, off chain, and then write some tool that will analyze this block and then authorize people to vote or not, and then you have to collect these signatures off-chain, and you'll be able to produce a reliable image of who was allowed to vote at a point in time and who actually voted, right? But there's obvious limitations to that because you can do it off-chain, but you can't really have a smart contract actually implement, like verify this kind of a thing. You can't give to a smart contract the state of a block in the past, analyze who was allowed to vote or not, and who voted what. This would be way too computation intensive. Well, you can do that in StarkNet. You can give to StarkNet the content of a block, an Ethereum block in the past. You can have StarkNet verify the content of that block, verify the state of specific smart contract in that block, and then have different mechanism in place. You can verify the Ethereum signature, so you could collect data off-chain and have a StarkNet smart contract produce a proof that somebody did something depending on something that happened on L1, and produce a proof on L2 that can eventually have actions on L1. And that's the basic concept behind something we presented a few weeks ago, which is called Stark Vote, which is a partnership with Snapshot, which you guys might be familiar with. And this specific example does give you an idea of how you can exploit L1 data on L2. I don't know, Ariel, if I've said something you want to correct, or if you have something you want to add on this.
No.
Perfect. So who's going to be the first to write a Bitcoin miner on StarkNet? I'm not sure you could mine on StarkNet, but you can definitely interpret the content of Bitcoin block on StarkNet. So that's exciting. And Yoni gave more information regarding the GPU shaders. So think running a step of inference for a machine learning model or frame in a 3D game or Photoshop-like drawing program. So I think what you're saying is like how complex can the execution be, and if you can run logic that is akin to what you would run on a GPU in a computer. Yeah, do you want to comment on that, Ariel? I think the question basically is like, how far can you go with the complexity on
I mean,
on Cairo?
if your program requires, I don't know, thousands of dollars to run on AWS, for example, then it's probably going to be harder to implement it in a provable way. So you don't have the overhead, the insane overhead of Ethereum, but you still do computation. So if you're like doing a very heavy model training, then you're probably eventually going to get into the same barriers that you would if you were to use your own very strong computers. So there's no magic. We're not. There's magic in the proof aspect, but somebody out there will have to execute this computation. Just not. It won't have to be everyone. Yeah, I'll just say something about privacy. By the way, there are no syntactical questions, so I'm guessing that's because you're all writing it very easily, and the code is compiling for all of you. So about the privacy question, in our implementation right here in this voting example, then we don't do anything related to privacy. But I will say a word about using, for example, ZK snarks for private voting. So you could use ZK snarks or starks for privacy. It doesn't really, the technology of the proof isn't really important here. What is important that when we're talking in a layer 1 and layer 2 context, information, having a zero knowledge proof is far from enough because somebody sends the transaction to a mempool eventually. So what point does it have to publicly send my vote to some poll, but having the proof expose no information on it? I mean, it's a little silly because, okay, I won't try to read it from the proof. I will simply look at the mempool. To implement a system which truly exposes no information, you need more than the proof to not leak any information. This is similar to Zcash, which on top of using ZK proofs, they also had a complete design ensuring privacy. So the ZK proofs were just one element in a much larger system, a crucial element, but just one element. So you could implement something like this on top of StarkNet. Right now, our proofs are not technically ZK, although I believe it practically it's not a very practical task to extract information from it. But if you care about privacy, you need to do stuff in the business logic of your particular application. Because if you simply expect someone to send you the transaction, then obviously you'll get no privacy regardless of what proof you're using.
So there's another question. In the usage workflow, can I deploy my own StarkNet or shall I use the one provided by Starkware? Well, should you use Ethereum or run your own chain? You can do both. It depends on your use case. But in most use cases for app developers, you want to be on Ethereum mainnet, right? So you probably will find more apps and more content and more infrastructure on the StarkNet, the public StarkNet. And when you say the one provided by Starkware, once again, I want to stress that right now we're developing it and we're maintaining it, but this won't stay like this forever. Eventually it's going to have legs of its own and it's going to be outside of our control. So we still have some time. Is there anything to say about accounts on StarkNet? OpenZeppelin uses. So can you talk a bit about account abstraction, Ariel, on StarkNet?
Let me read the question again carefully. Okay, so we are still working on the specific details of account abstractions. We're also working closely with OpenZeppelin. You can see their initial account contract right now. You can just go to the repo and see how they implemented it. So yeah, they do use get caller address, which returns the contact address calling you. How does this work with ETH accounts? So if you want to bind your account contract with your ETH account, one way, for example, to do it was to just have a field in your contract account which represents your Ethereum address and somehow work your logic around that. So accounts, if we're going down the account contract routes where your account is represented by a contract like any other, then you can contain information regarding your Ethereum address on it as well. And you might require Ethereum signatures which correspond to the public key you're saving there and this sort of stuff. Yeah.
So there are a few programming questions that I will let Yonatan maybe answer. There's another question which is interesting, is Ethereum gas helps preventing getting the smart contract in an infinite loop. What mechanism prevents that on StarkNet if not using gas? So two aspects. The first one is this is still an area of discussion and experimentation. So there are very interesting discussions regarding this very topic. So do join the discussion if you're interested and you have good ideas on that. I'll just say that when you run a Cairo program, there's a number of steps that you need to execute, and you can put a cap on the number of steps that you'll allow in your program. I think, Ariel, do you have something else to add on that topic? How do you prevent grieving attack?
Not right now, yeah.
Okay, cool. Thank you. And then there are programming questions, which is, I guess, related to the exercise. And I think it's easier if we answer this by in writing. So do check the answers in the chat.
All question. So first of all, notice that Yoni is answering questions in the chat. So take a look there as well. So our compiler currently doesn't support OR. I'm guessing that it's not conceptually hard to implement. It's just not a top priority. So yeah, this is why we're using this particular assertion here. Okay, and regarding the previous question, so we will have some DOS prevention mechanism that will allow you to charge somehow for computation. For example, if somebody in an infinite loop, we can limit the number of steps. There are some technical obstacles which we are currently dealing with, but you can expect some notion of guess, definitely. In the alpha version, we won't have it just yet, but you can expect something along those lines. Yeah. On time?
Minutes, still 2 minutes to go.
Okay, no problem. So maybe I'll use those 2 minutes to refer to the last question about implicit arguments. So essentially, we need to have access to them and being able to update. Those are pointers, and every function that accesses the storage needs to be able to track the current location of those pointers. So under the hood, it's not particularly sophisticated. Under the hood, what's happening is that those variables, the updated value of those arguments is actually returned. So this is a helper function. It receives implicit arguments, and here it looks like it doesn't return anything, but under the hood, those parameters actually changed, and they're returned. It is just so the user won't have to always return explicitly those arguments which are not directly related to his business logic. So yes, they do appear here, but you can think of it as they only appear once in a sense. And from that on, they're just implicitly passed to other functions that make use of them. So I hope that sheds some light on it. Again, for more complete explanation, see our docs.
And we are at about 15 minutes, so we can now move with the correction of the exercise.
Okay, great. So again, I hope you all got it right. And for those who want to enjoy the show, this is the first verification that the voter is already registered to the poll. So we're maintaining the register voter storage variable. So we simply read from it and assert that it is non-zero. So it is a flag. Recall that it is a mapping from a poll ID and the voter public key to a flag, which indicates if the user is registered or not. Then we do almost the same thing to verify that the user hasn't already voted. So we're going to voter state, and we're reading the flag which says whether or not the user has already voted. And again, we're asserting that this value is 0. There we asserted that the value was not 0. Now we asserted that the user hasn't voted. And now we have the verification of the voter signature. So exactly like the previous signature verification, only now the message that we're signing on is the hash of the poll ID and the vote. Okay, because the user is signing on the pair poll ID and vote. And obviously the public key with respect to we're verifying the signature is the public key of the voter. In the previous verification, it was the public key of the owner, and again we're passing those R and S. So we will only pass this verification if the signature is valid. Okay, now finally we're ready to implement the actual voting logic. So we have the vote function, which takes as explicit arguments the poll ID, public key of the voter, his vote, and this R and S representing the ECDSA signature. And we first of all call our helper function, which does all the verification, checking that the user is registered to the poll, checking that he didn't already vote, checking that his signature is valid. And if we were able to pass this line, this means that everything works, and we can simply update the voting state. So we're reading what is the current number of votes for the option that this user wants to vote to. So we're reading from voting state, and the parameters we're sending is the vote of this particular user. So we call it a mapping from the option to the number of votes. So we're reading this mapping in this particular option, and then we're writing to this same storage variable the updated value. So the same key, the poll ID, and the vote of this particular user, but now the value is the current number of votes plus 1. And one thing before we're done is update the voter state. So recall that the storage variable we need to maintain, so we need to remember that the user has already voted. So we're setting this mapping to 1. And this is actually in our, we have our voting logic complete. Okay, great. So now we move on to the next part, which is composability. So here we're basically going to show you how to interact with other StarkNet contracts. Okay, so this is a dummy contract for vote recording. So think of it as a contract which holds the result of all polls. Okay, it has one storage variable, a mapping between a poll ID and the result. It has one external function and one view function. The external function record takes as arguments a poll ID and the result and simply writes, records the result. And the get result does exactly what you would expect. It reads the current value from the mapping and returns it. So I know if you want to yell that there is no verification here, and anybody can call record even if he's not the poll owner. So yes, this is just a dummy contract to demonstrate composability, but you're essentially right. To make the system meaningful, if you want vote recording, then you probably need to verify the signature of the poll owner. Okay, so how can we interact with this new contract from our primary voting contract under which we implemented all that logic before? So we're going to add 3 elements to our contract basically. So the first one is another storage variable, which is simply a single felt value, a single field element. You can see it from the fact that this function takes no arguments, so there's no key required. It is not a mapping, it is just a single variable. And this storage variable represents the address of the recorder contract. Okay. We will also add a constructor to our voting contract, which will take as an argument the address of the recording contract and save it to the storage variable. So now, as opposed to the previous situation, to deploy this contract, we're going to have to send an argument. This argument will be the address of the vote recorder contract. Okay, and the constructor simply takes this address and stores it in storage variable, very similar to how you do this sort of things in Solidity. And then we also have to define the interface of the contract that we're going to use. So here you see the contract interface decorator and special syntax namespace and the name that we're going to use to actually call the contract. And here we define the function that we're going to call. So we're going to call the record function, which we've seen before. It takes a poll ID and the result. Okay, so now having those 3 parts incorporated in our contract, we're ready to interact with this recording contract. Okay, so let's see how this is actually done. So now we're adding a new function to our voting contract. It is called finalize poll. Again, the implicit arguments which we're used to, it takes only the poll ID as an argument. Okay. And what it does is simply read, it first accesses the address of the recorder contract. We call it this storage variable keeps the address of the contract that we want to interact with. Then from the voting state, we take the number of no votes and the number of yes votes. And then, bear with me, I'm going to jump a few lines. We're checking which is bigger using the is less equal library function, the number of no votes or the number of yes votes. So this returns 1 if the number of yes votes is bigger or equal. And now we can compute the result of this particular vote. And we're not representing it as a Boolean value as to not create a mix-up between a 0 result for a poll and the 0 default value for storage variables. So we're going to use the short string syntax in StarkNet. So when you write the constant string yes under those buckets, what it does is represent the string as a felt. So this is the way it encodes it. It takes the ASCII encoding and represents it in a big endian encoding. So notice that the result is simply the multiplication of yes by result and no by 1 minus result. So if the result of the poll is 1, okay, it means that the number of yes votes is bigger, then this is going to be 0, and the result is going to be the field element representing yes. If, on the other hand, this is going to be 0, this means that the number of no votes is greater, this is going to be 0, and this is going to be 1, so the result will be the field element which represents the string no. And now, once we have the string representation of the result we want to record, we're simply calling the record function. So we define the namespace under the name result recorder. This is what we defined here. So we can simply write result recorder and access the function that we have here, record, and we're accessing it as if you would access a function inside the contract. So with a simple distinction that the first argument is always the address of the contract you want to interact with. So the record function takes 2 arguments, and here we send 3 arguments, the first being the address of the contract, which we take from storage. So this is how we were able to interact with other contracts. And now we leave it to you to add another external call to verify that the poll wasn't already finalized. So in the finalized poll, before we actually record the result, we want to verify that this wasn't already finalized. And let me just show you again the code for the recorder contract. So we already used the record function in our voting contract. But note that we also have this view function, which we didn't use, which takes the poll result. So think how you would use this function to verify that the vote is not already settled and call it from the voting contract we've implemented so far. So again, what you need to incorporate is these new definitions, and good luck. So you have 5 minutes for it, and I leave it under this slide, so you'll see what you need to add in order to be able to access it, access the new contract. Obviously, again, you have all the code in the Notion document, so if you need to, you can also look there. Okay, so we're gonna give you 5 minutes, and I'll take a look at the questions in the meantime. Okay, I leave it to Henri, who led our intermissions.
Hello again. So there are 2 questions. There are less questions in the beginning, so it's going to be easy. How does Cairo handle longer strings? For example, strings cannot be in one felt. I don't think we have a native support for strings or for longer strings.
We still don't have any library supporting it. You feel free to implement it and post it on our Discord. People will be very glad to hear it. But yeah, we do. There needs to be some handling of this. But all the tools are out there just waiting for us or somebody else to implement it. Yeah.
Somebody is asking, how can I improve myself on coding about Starks? So to be honest, I think StarkNet is more of an application running on top of Starks. You don't really need to deeply understand Starks to write StarkNet smart contracts. So I'm not sure StarkNet would be the place for you to learn how to reason and write about Starks. That being said, our documentation and our code, which is open source, is a good place to learn how we implemented stuff. How would you go about it, Ariel?
So there are our documentation. Definitely also join our Discord to interact with other developers and see what kind of problems they're tackling and the advice they're giving. There's also the tooling around StarkNet. Start with our documentation and just start writing dummy contracts until you slowly get better. So that's why, for example, we're doing this workshop. Yeah. So this is the kind of thing you would want to improve it if you're going to develop dApps on StarkNet. This is completely unrelated to improving your understanding of Starks. Again, I can't stress this enough. You don't need to get into this type to the mathy papers to be an excellent top of the line StarkNet developer. The analogy between a very sharp Solidity dev to a very sharp StarkNet dev would be understanding the ins and outs of Cairo, and this is unrelated to Starks. I wouldn't say unrelated because Cairo was built to support Stark proving of execution, but you don't have to know anything about Starks to understand very deeply how Cairo works and how StarkNet contracts utilizing Cairo work.
Ariel. And I think that's most of the questions we had. If you have others, feel free to answer them. Other than that, we'll still have 2 minutes to go, so let's wait a bit.
So yeah, so we're moving to the solution. I see just another question regarding the guy who's finishing his master. Then yeah, join our Discord and see what projects are available. I mean, there are tons of projects going on. If you have any cool idea, then be sure to let us know. And yeah, go nuts. And again, feel free to ask our help on Discord. We're very interested in any StarkNet ideas. Oh, you were the one who asked about getting deep into Starks. So yeah, if it interests you, the papers are out there. Go nuts with that as well. Okay. Okay, so I'm going to move on to the solution. So I'm reminding you, we want to verify that the poll wasn't already finalized. And to do that, we simply want to call this view function on the contract. We want to see the poll result. Recall that when recording, we substituted the field representations of yes and no. So if the poll result is 0, this means it is still set to the default value. So the poll is still ongoing. So all we need to do is read the poll result from the recorder and verify that it is still 0. Okay. So these are the 2 parts that you need to add to the contract. You need to add to the namespace the other function that you're going to use. So this is the get poll result. You wouldn't be able to call it inside the voting contract unless you explicitly defined its signature here. And now all the logic that you need to implement to verify that the poll was not already settled is calling get poll result and asserting that the value is 0, which means it is not yes or no yet. And if it was 0, then we're able to continue to the next line, which was recording the result. Okay, so we're actually done with our voting contract. I hope you all enjoyed the exercises and the questions. So I'm gonna briefly interact with it before going ahead with telling you what else you can do to improve your StarkNet experience. Okay, so let me just share my browser. 1 second, I need to reshare here. Okay, so you guys should be able to see my screen now. This is our block explorer, Voyager. So StarkNet is currently deployed on the Goerli testnet, and it will be deployed on mainnet in its alpha version by the end of the month. So right now you see this exact voting contract, which I pre-deployed. So if you don't believe me, you can later check out that the bytecode here corresponds to the voting contract. And as you can see, I pre-submitted 2 transactions to it, so I deployed it. This was a transaction deploying the contract, and I submitted 2 additional transactions. Those were initializing some poll, and the next one was giving some voter permissions to that poll. So stuff we implemented like an hour ago, in case you forgot. So you see under write contract, you can see external functions. Under read contract, you can see view functions. So these were all our external functions that we implemented. And this is the view function that we implemented. So you can see that, trust me, when I say I initialized a poll with the ID 2022, and as you can see, nobody has voted on it yet. So the number of votes is 0 for both no and yes. So what I'm going to do now is send a transaction through Voyager. It is not the only way to interact with StarkNet. So to interact with StarkNet using our Cairo Lang package and the CLI, view our documentation. But right now, I'll just, for the purposes of demonstration, will interact using Voyager. So what I'm going to do is I'm going to vote. So I've prepared the signature that I want to put here. So this is the poll ID that I want to use. And now let's see. Hopefully these are going to be the correct parameters. Otherwise, I won't be permitted. This is my public key. And now I'm going to attach my signature. Okay, so I'm going to vote yes. Don't ask me to vote no, because I didn't prepare a signature for the no answer. So I'm going to vote yes, if you don't mind. Let's imagine this is a question where the answer is obviously yes. Okay, so hopefully these are all the valid arguments for voting. So I'm going to send this transaction. Okay, so this transaction is now sent, and we're waiting for it to be included in a StarkNet block. So the life cycle of a transaction is first being captured by our system or by any other sequencer when StarkNet will be decentralized, and after it is accepted on L2, this is the term we use, at least in Voyager, we're waiting for a final confirmation that a proof attesting to the validity of this transaction was also accepted on Ethereum. Right now, obviously, on the Goerli testnet, because we're working with Goerli. Okay, so that's basically how you can use Voyager to interact with your contract. So just see what other nice features you can extract from here. So let's see how our transaction is doing. Okay, it's still waiting to be included in a block. So for now, let me just tell you what else you can do. Okay. So here we used the playground to write code, which is actually a less optimal way to go if you want to write if you want to write Cairo or StarkNet contracts more fluently. So we have the Cairo lang package, which comes with the compiler and the CLI for interacting with StarkNet. Everything is explained in our documentation, so please feel free to read it. And obviously, if you find some explanation lacking or you're encountering some problems, join our Discord and ask any questions in any range of difficulty, and we'll definitely answer. And for those of you who just want to start from the ground up, there's the StarkNet tutorial. So start from there and see where it takes you. There are also additional exercises in the Notion document. So yeah, you have different avenues you can pursue. So good luck. Let's just see what's our status there. Okay, so our transaction was accepted on L2. Let's just see that I'm getting the new value right. So the poll ID was 2022. Okay, great. Now the number of yes votes is 1. This is very exciting. We were able to pass the verification. This means all the arguments I previously gave are indeed the correct ECDSA signature for my public key. So thank you very much for going along with writing the contract. I hope you enjoyed it. I hope you also found it helpful. And again, feel free to visit us on Discord. And if you have cool ideas for dApps on StarkNet, let us know. I'm Feed the Fed, so feel free to ask me anything. Henry, do you want to add something?
No, I think, yep, thank you to everyone. There are 2 questions we can answer quickly, maybe. So where to find a good technical description of how the StarkNet network works, sorry. Verifier, prover, L1, L2 connection, and all of these parts. So we're building that documentation, and we are documenting things as we develop them. So not everything is documented. You will not find that much about verifier and prover yet, but it will come. You'll be able to run a StarkNet full node by the end of the year. You should be able to do it. So that's going to be a big step. L1, L2 connection, this is fairly well documented, so you can look up at the documentation. So mostly I would encourage you to join our Discord, and we will publish a discourse platform soon where you'll be able to find more information and see the discussions in real time regarding the network architecture. And then there's another question about, could you talk a bit about the concept of hints? Is it possible to fetch data from external Python code? Yes, but actually no. So the concept of hints is a concept of Cairo. It's something you can actually use in Cairo, but you can't use in StarkNet. So Ariel may correct me if I'm wrong, but basically the program you are running in your when you want to prove something will basically require you at some point, for example, to prove that you know the square root of 25. You could supply the value 5 and the program would be fine, or you could just run some Python code that calculates this value. From the point of view of Cairo, it doesn't change much. The important thing is that you have the actual value to verify that the program executed correctly. So this is why in Cairo, when you're writing a general purpose Cairo program, you can use hints. Now in the context of StarkNet, this is a bit more difficult because the proof will not be run on your computer. It will be run by the prover, and it's hard to be sure how the hint will work in the prover's environment. So that's why you can have generalized hints in StarkNet smart contract. That being said, I think we have a white list of hints you can use. So you can use some hints, but not anything you would like to add. And I hope that answers the question.
Just add that some library functions are actually using hints. So for example, if you want to search for an element in a list, then doing it non-deterministically would be guessing the location of this element in the list and then verifying that this is indeed the element. You need a hint for that, but luckily we've implemented it for you. This hint is whitelisted, and you can do it by simply calling the library function.
Which is pretty cool, actually. I don't know if you've ever written a Solidity smart contract. You have to look for a value in an array, and it's a pain in the ass because it's got so much money. There's nothing specific for that. And now, I mean, in StarkNet, you can just say, yeah, do it in Python and give me back the answer, which is kind of cool. Anyway, so thank you for everything. I'll do join our Discord, join the conversation. And thank you to ZKValidator for having us. It was fun.
Yeah.
And,
thank you so much for doing this. Ariel, we noticed that you were also sporting, I don't know if you can show this off,
definitely
the ZK hack swag. Yeah, we actually have a ton of t-shirts, so we're going to try
I got
to find
one, but my brother stole it from me.
Oh, well, we have a lot of them, so actually we're gonna try to find a way to get it out to people if people want these very cool shirts. I want to say thank you so much for doing this workshop.